Hi, my name is Joanna Wu, and I am a planner with the Department of Natural Resources. In this video, I will be explaining how to evaluate potential impacts to public river corridor views in the Mississippi River Corridor Critical Area, or MRCCA, using Google Earth Pro. The MRCCA guides land development for the 72-mile stretch of the Mississippi River through the 7-county metro area. The MRCCA was established in 1976 to protect vegetation and habitat, scenic views, and water quality while continuing the development of commercial and recreational resources. This area is primarily regulated at the local level through land use plans and zoning ordinances. The river corridor shares a boundary with the Mississippi National River and Recreation Area. The MRCCA rules established a basic framework for protection to preserve scenic views. The statewide rules refer to this as Public River Corridor Views, or PRCVs. PRCVs are significant views that are detailed in the MRCCA section of each community's comprehensive plan. The 30 local governments along the river corridor have identified at least one PRCV in their plan, if not more. Here is a PRCV that Champlin identified in their plan, which we will be looking at later on in this video. Each local government's MRCCA ordinance has triggers for when impacts to PRCVs should be evaluated, such as vegetation removal and land use development. Impacts to views must be evaluated for determining maximum allowable building height in certain MRCCA districts. These districts and height standards are established in the MRCCA rules and described on the DNR website. The state rules have not directly specified guidelines for how a local government should conduct a visual analysis. This video will introduce one method for analyzing the visual impacts of a proposed building using Google Earth Pro. Google Earth Pro is a free online software that can help assist with assessing potential impacts to PRCVs in the MRCCA. This software allows you to simulate the potential impacts of proposed buildings you may be working with. To navigate and move around in Google Earth, you can use the tools on the right side of the screen. To move about the map, you can use the compass on the top right or the one below it. To freely roam around the map, hold and drag the mouse in the direction you want. To change the angle or perspective of the map, hold down the Shift key and drag the map up or down. You can also use the Control key and mouse scroll to rotate the map. To zoom in and out of the map, you can use the mouse scroll or the slide bar on the right-hand side. To enter Street View, drag the stick figure onto the map. When you are done, click Exit Street View. On the left side of the screen, you can use the search bar to easily find places on the map. To perform a visual analysis, the main tools that you will use are Placemark and Polygon. Before moving on, make sure that the Terrain layer and 3D Building layer are turned on in the Layers tab on the bottom left. For demonstration purposes, I will be simulating a hypothetical building proposed in a park in Anoka. According to the MRCCA rules, this area is in the River Towns and Crossing District, or RTC, where buildings over 48 feet can only be approved with a conditional use permit. This would require a visual analysis of impacts to PRCVs. First, click on the Add Placemark button located on the top of the page to identify the location of our PRCV. The PRCV that we will be analyzing is Mississippi Point Park, which is identified in Champlin's MRCCA plan. Drag the pin to the location of the PRCV. Make sure that the point you are analyzing is not behind any trees, structures, or other view obstructions. If your view is impeded, you may need to move the pin slightly to get a direct line of sight to the proposed building. When you are set with the location, you can change the symbology and the name of the location. We will name our placemark Champlin PRCV. Afterwards, click the Altitude tab and change the altitude to 2 meters. This is because it is roughly around eye level, and change it to relative to ground. When you are done, hit OK. Click on the Add Polygon button on the top of the page. Just like placemark, you can change the name and symbology. Click on the map to draw an estimated footprint of the proposed building. After you are done, click on the Altitude tab. For the sake of this hypothetical example, the proposed building will be 65 feet high. In Google Earth Pro, meters are used for all dimensions, so 65 feet can be converted to 20 meters. Change it to relative to ground, and check the Extend Sides to Ground box to showcase a building to scale. When you are done, hit OK. Now you have all your components set up for your visual analysis. Remember to make sure that the terrain layer and 3D buildings layer are turned on before moving on to the next step. Right-click on your placemark pin on the map and click on Show Viewshed. The area in green is your viewshed. These are all the areas you can see from the placemark and from an altitude of 2 meters. To get a different perspective, you can also zoom into your placemark and use the hold shift method and change the angle of the map. From this angle, you can see the building and its potential impacts to the view. When you are done, hit Exit Viewshed. This visual analysis tool can be used in scenarios like this demonstration or in other situations such as development on the bluffs, skyline, or high-value scenic areas. Again, this is just one method to analyze views. It is limited in its capabilities and would not be able to evaluate things like vegetation removal. Local governments are encouraged to work with developers and other individuals to evaluate views and mitigate their impacts and use different softwares or methods. Thank you for watching this video on the MRCCA visual analysis. If you have further questions, please refer to the Minnesota DNR's MRCCA website.